Right.
Have you ever, like, really stopped to think about how fast technology is moving? Like, it's kind of crazy when you think about it. Yeah. Like,
Oh,
just a few years ago, we were all like, oh, AI is going to take over the world. And it's, kind of a joke. But
right.
now,
Yeah.
it's like, not so funny anymore, is it? And then you have fighter jets. Like, those things are insane.
Right.
The speed, the maneuverability, it's like something out of a movie. So what happens when you combine the two?
Well, that's exactly what we're diving into today. It's like AI and fighter jets.
Yeah, AI and fighter jets. And it's not just some, far-off sci-fi concept. This is happening now.
Right. It is. And it's pretty ambitious stuff.
Oh, yeah, we're not talking about just, small improvements here and there.
Mhm.
This is like potentially changing the whole game of aerial warfare, like
Yeah.
how we think about it, how we fight, everything. So,
Yes, it is. A lot to consider.
yeah, a lot to consider.
Mm.
And luckily, we've got some really cool stuff to go through today, some great material to work with.
Yeah.
We've got this PDF titled AI for Fighters. Very straightforward,
Straight to the point.
straight to the point. And then there's a survey note that's just packed with, like, super interesting details. I mean, really fascinating stuff.
Lots to unpack.
Lots to unpack. So our mission for this deep dive is basically to break it all down for you. Like, take all the key insights about AI and fighter jets and, present them in a way that's hopefully engaging and understandable without, making your head spin too much.
Right. So let's not overload anybody. Let's start maybe with the fundamental question. What are they even trying to do? What's the big picture goal here?
Yeah, good question. So the big picture, the core objective, if you will, is to develop AI that can operate, with a high degree of autonomy in a fighter jet.
Wow.
I know, right? We're talking about AI systems that can learn from, like, the best pilots in the world.
In real time?
In real time, adjust their strategies on the fly.
Yeah.
And provide crucial assistance during combat. Like, imagine having an AI wingman who's constantly learning and adapting.
I mean, that's the dream, right? Like seamless teamwork between human and AI.
Exactly. Seamless teamwork. That's the vision.
But it makes you wonder how much weight is really behind this vision. You know what I mean?
Oh, yeah, you're right. Talk is cheap, as they say. But here's the thing. There's serious money being thrown at this. Like, a lot of money. The U.S. Air Force, for example, they have this program called the Collaborative Combat Aircraft Program, CCA for short, and they're pouring money into it. I mean, we're talking $8.9 billion over 5 years. That's starting in fiscal year 2025.
Okay. Wow. That is serious commitment.
Yeah, that's not messing around. That's a clear sign that they're taking this seriously. But, $8.9 billion doesn't just magically appear out of thin air. It's not like, oh, hey, let's try this AI thing. Why not?
Yeah.
It's built on, years of research and development.
Yeah, you're right. So what came before this?
Well, they had this program called Skyborg, sort of like the precursor to CCA. And Skyborg was all about, pushing the boundaries of what's possible with autonomous drones. Figuring out the tech, the algorithms, the whole 9 yards. And now we're seeing that research translate into real-world systems. I mean, there are companies like Anduril, they're developing this drone called Fury, and General Atomics, they have the Gambit. Both of those are expected to be flying in 2025.
Yeah.
And they're leveraging all that knowledge gained from the Skyborg program.
So it's like a natural progression from research to actual deployment.
Exactly. It's all connected, but it's not all smooth sailing.
Yeah.
There are some pretty massive challenges they're facing.
Yeah, I can imagine.
Oh, yeah. I mean, think about it. Aerial combat is incredibly fast-paced,
Yeah.
right? It's all about split-second decisions.
Yeah.
So the AI needs to be able to process information and react in, like, milliseconds.
Milliseconds.
And we're talking extremely low latency. And then you have the physical environment. These fighter jets, they pull some crazy G-forces. And there's all this electromagnetic interference that can really mess with sensitive electronics. And then, of course, you have cybersecurity. You can't just have any old AI system controlling a fighter jet, right? You need to make sure it's protected from hackers and all sorts of malicious attacks. And then there's the whole ethical dimension.
Ah, the ethics.
Yeah, it's a big one. We're talking about machines making life or death decisions in combat.
It does raise a lot of questions.
It does. It raises a lot of questions. And there are no easy answers. But, we have to start somewhere. We have to have these conversations. But all of that is software and AI models and algorithms. And all of that is useless without, well, the hardware.
Right, the hardware.
Yeah.
The actual brains of the operation.
Exactly. And we're not talking about your average laptop here. This is some seriously specialized gear engineered to withstand conditions that would make most computers melt.
Yeah.
I mean, we're talking radiation-hardened GPUs.
Yeah.
GPUs are those processors that power like all the crazy graphics in video games.
Yeah.
But these are special GPUs designed to function even when exposed to, like, radiation.
Yeah.
Which is pretty wild when you think about it.
That is wild. So are they using, like, the same kind of chips in spacecraft?
Pretty much. And then you have FPGAs, field programmable gate arrays. Those are really cool. Basically, they're computer chips that you can reconfigure after they've been manufactured. So you can, like, adapt them to new tasks and challenges as they come up, which is super important in a field like AI where things are constantly changing.
Right, because if you bake in the programming, at the factory, then you're kind of stuck with that.
Exactly. And redundancy is key. Everything needs to be redundant. If one system fails, you need a backup ready to go instantly. But, one specific hardware component really caught my eye.
Okay, I'm curious.
It's the Edge Cortex Sakura series, AI accelerators. Have you heard of these?
I have not.
They're really impressive. I mean, these things have been tested and validated for space missions, like actual space missions.
Wow. Okay, so they're good?
Yeah. If they can handle space, they can probably handle a fighter jet. But here's the really cool part. They're designed for extremely low power consumption.
Which is vital in an aircraft.
Vital. I mean, power is a precious commodity on a fighter jet. So you have the Sakura 2, for example. That little chip can deliver up to 60 tera operations per second, or TOPS. That's a lot of processing power and only uses 8 watts. Like, that's less power than a light bulb. And to me, that's the real takeaway here. It's not just about raw power. It's about efficient power, power that can actually be deployed in these really demanding environments without, draining the aircraft's entire energy reserves in 5 minutes. It changes the game entirely.
It makes you wonder how much further they can push that, like how small and efficient can they make these things?
Oh, for sure. I mean, the possibilities are endless. But all of that processing power is just one piece of the puzzle. You need to feed the AI with information about the world around it.
So sensors, that's what I was thinking.
Yeah, the sensors, yes. And these fighter jets are packed with them. You have radar, of course, the classic radar. It's been around forever, and it's still super important. But they're also using LiDAR now, light detection and ranging. That's kind of like radar, but it uses lasers to create these incredibly detailed 3D maps of the environment. And then there's IRST, infrared search and track systems. Those are all about detecting the heat signatures of other aircraft, even from really far away. And there's this super cool technology on the horizon, hyperspectral imaging. That's like next level stuff. Basically, it allows the AI to analyze the light reflected off of objects and identify them based on their unique spectral signature. So, like, really hard to camouflage yourself in that kind of sensor. And of course, you need somewhere to put all of that information, right?
Right, storage.
And that's where ruggedized SSDs come in. They're solid-state drives that are designed to handle all the vibrations and G-forces without, losing all your data. And then, of course, you need to share that information with other aircraft and ground control, right? So for that, you have secure data links like Link 16 and BNet. But here's the thing. You can't always rely on those data links. They can get jammed, they can go down, especially in a combat zone. So the AI needs to be able to process all that sensor data and make decisions locally in real time, even when it's cut off from the outside world.
Right, it needs to be able to think for itself.
Exactly, think for itself. So that's the hardware, the sensors, the storage, all the physical stuff. But, the real magic happens in the software, the AI itself. And that's where things get really interesting.
So how does this AI actually learn?
Well, the main method they're using is called reinforcement learning, or RL. It's kind of like, imagine you're teaching a dog a new trick. You give the dog a treat when it does something right, and it learns to repeat that behavior. RL is similar.
Oh.
The AI takes actions in a simulated environment, and if those actions lead to a positive outcome, like, say, successfully evading a virtual enemy, it receives a reward. So over time, it learns which actions are good and which actions are bad. It's constantly experimenting and improving. But, the world is not a static simulation, right?
Yeah.
Things change constantly. So they're also using something called online learning.
Online learning.
Online learning. That means the AI can keep learning and updating its knowledge even while it's flying a real mission. It's not just stuck with what it learned in the simulator. It can adapt to new situations as they arise. And then there's federated learning.
Okay, I didn't know that one.
So federated learning is really cool. It's a way for multiple AI systems to share their knowledge and insights with each other without actually sharing their raw data. So imagine you have a bunch of fighter jets all equipped with AI. They can all learn from each other's experiences and become smarter as a group without compromising the security of their individual data sets. It's like a hive mind, but with privacy.
Oh.
Yeah. So all of these techniques, reinforcement learning, online learning, federated learning, they're all pushing the boundaries of what AI can do in a fighter jet.
And there's like actual proof that this works, like in the real world.
Oh, yeah. There have been a ton of studies that show how effective RL can be in air combat. Like, they've trained AI systems to perform complex maneuvers, make tactical decisions, and even outmaneuver experienced human pilots in simulations.
Oh, wow. So they're already beating us at our own game.
It's pretty wild, right?
Yeah.
But, it's all about pushing the limits.
Right.
And it's not just about the algorithms themselves. It's about the underlying AI architectures as well, like how these systems are actually built. So one of the key architectures they're using is deep neural networks, or DNNs. Those are really good at taking in massive amounts of data, like from all those sensors we talked about, and making sense of it. They can recognize patterns, classify objects, and basically build a really detailed understanding of the world around them. And then for analyzing sequences of events and making predictions, they're using transformer networks. Those are really good at understanding context and relationships within like a series of actions, which is super important in a dogfight where you need to anticipate your opponent's moves and react accordingly.
Makes sense. So how do they like train these AI systems to handle the complexities of real world combat?
Yeah, it's not like they can just, throw a bunch of AI into real fighter jets and let them figure it out. It's way too dangerous and expensive. So they use a lot of simulations, like digital twins. Those are virtual replicas of the aircraft and the environment.
Oh, okay.
Yeah, and they use really sophisticated simulators like DCS World. Have you heard of that one?
Yeah.
Yeah, it's like a super realistic flight simulator that a lot of pilots use for training. And they're using those simulators to train the AI as well. The AI can fly countless missions in the simulator, experiment with different tactics, and get really good at making decisions without any risk to human life or expensive hardware. And then the CCA program, that's all about taking those AI models out of the simulator and putting them into actual drones, like real-world drones that can fly and fight alongside human pilots. So it's a step-by-step process, from simulation to reality.
It's a really smart approach, honestly.
Oh, okay. It is. It's very methodical, but whenever you're talking about autonomous systems making decisions in combat, you have to address the safety concerns and the legal ramifications.
Yeah.
And all of that.
Yeah, I can't just ignore that part.
Exactly. So safety is the absolute top priority. They're building in all sorts of fail-safes. Like, the human pilot can always override the AI if something goes wrong. And they're using existing safety standards from the aviation industry, like DO 178C. That's a really rigorous set of guidelines for developing software for aircraft. But AI is different from traditional software, right? Get, learn, and adapt. So they're also working on developing entirely new certification frameworks specifically for AI in military aircraft. It's a complex challenge, but it's absolutely essential. You can't just have AI systems flying around making decisions without, being absolutely certain that they're going to behave safely and predictably.
Right. It's a whole new level of complexity.
It is. And then, of course, there's cybersecurity. That's a huge concern. They're using all sorts of advanced techniques to protect these AI systems from hacking and tampering. And from a legal standpoint, there's a very clear mandate for human oversight in the use of lethal force. The AI can't just decide to, fire a missile on its own. A human pilot always has to be in the loop for those kinds of decisions. It's all about accountability.
That makes sense. But, it's interesting. The FAA, the Federal Aviation Administration, they're also working on safety guidelines for AI in civilian aircraft. Do you think that might have any influence on what the military is doing?
Yeah, that's a good point. I think there's definitely some overlap there. Both civilian and military aviation are grappling with the same fundamental challenges of integrating AI into these really complex systems. So it makes sense to share knowledge and learn from each other's experiences.
Yeah, it does. So we've talked about the goals, the hardware, the AI training, the safety and legal stuff, but how does it all work in practice?
Okay, so picture this.
Yeah.
A fighter jet is getting ready for a mission.
Okay.
First, they load up the AI models onto the aircraft systems. These are the models that have been pre-trained in those super realistic simulators. And then they run some simulations just to make sure everything's working properly. And then once the aircraft is in the air, the AI starts taking in all that data from the sensors, the radar, the LiDAR, the IR tests, and it starts building a picture of the environment.
Yeah.
It can identify potential threats, suggest maneuvers, and even control certain aspects of the flight in coordination with the human pilot.
Wow.
Yeah, it's like having a super smart co-pilot who's always analyzing the situation and providing real-time insights. And then, after the mission is over, all the data that was collected during the flight is used to further refine the AI models. So the AI is constantly learning and improving with each mission. It's a really dynamic process.
And there are already, like, real-world examples of this, like things that have actually been done.
Oh yeah, absolutely. The Skyborg program has had a lot of success with these kinds of tests. Like back in December 2020, they had a drone with a Skyborg AI system successfully facilitate communication between an F-22 and an F-35. Those are two of the most advanced fighter jets in the world, but they don't normally communicate directly with each other because they use different systems.
Oh, wow.
Yeah. But the Skyborg AI was able to act as a bridge between them, which is pretty incredible when you think about it. And then in October 2021, they had two MQ-20 drones flying autonomously, coordinating their flight paths and responding to high-level commands. That was a huge step towards demonstrating true autonomous teaming in the air.
So this is really, really happening.
Yeah. Oh, yeah. And the CCA program, that's aiming even bigger. They want to have like 1,000 of these collaborative combat aircraft integrated into the Air Force fleet. I mean, that's a significant number. And it's not just the traditional defense companies involved. There are all sorts of innovative companies like Shield AI. They're developing fully autonomous drones specifically for combat. So this is a rapidly evolving field, and it's moving really fast.
It does make you wonder about the costs, though. Like, all of this
Yeah.
cutting-edge technology, it can't be cheap.
Oh, you're absolutely right. It's not cheap at all. The AI hardware alone per aircraft is estimated to cost somewhere between $500,000 and $2 million. And that's just the hardware.
Wow.
Yeah. And then you have the software development costs, which are also significant. We're talking about major defense contractors like Lockheed Martin and tons of research projects funded by DARPA, the Defense Advanced Research Projects Agency. And as we mentioned earlier, the CCA program has a budget of $8.9 billion over 5 years. So yeah, it's a massive investment. But, they clearly see this as a critical technology for the future of warfare. Yeah. And I think they're right. But it's not just about the money. It's about the collaboration as well. You need strong partnerships between government agencies, defense contractors, tech companies, and even universities to make all of this work. It's a truly collaborative effort. You need the best minds from all those different sectors working together to develop, test, and deploy these incredibly complex systems.
It's a huge undertaking.
It is. So as we wrap this up, what are the key takeaways here? I mean, we've covered a lot of ground. The ambitious goals, the crazy hardware, the AI algorithms, the safety concerns, the ethics, the collaboration. It's a lot to digest.
It is, yeah. So what do we want to leave the listener thinking about?
That's a good question. I think ultimately the biggest question here is, what are the long-term implications of all of this? I mean, we're developing incredibly sophisticated AI systems that can learn, adapt, and make decisions in high-stakes environments. And we're integrating those systems in some of the most powerful weapon systems on the planet. So what does that mean for the future of warfare? For the future of humanity, even? These are not easy questions to answer, but there's questions that we need to start thinking about now because the future is coming, whether we're ready for it or not.
It's moving pretty fast.
It is.
That is.
It's moving really, really fast.